Qualitative analysis of salts is a chemical technique used to identify the ions present in a salt by analyzing its physical and chemical properties and hence determine the identity of the salts. This method determines only the presence or absence of a particular ion in a given salt, but does not determine how much a particular ion is present. The procedure for testing salts in the laboratory consists of the following general steps. Number 1, make initial observations of the physical properties of the salts. Number 2, study the action of heat on the salts. Number 3, make aqueous solution of the salts to test for anions and cations present. And number 4, carry out confirmatory tests for cations and anions. Preliminary examination on the physical properties of a salt, such as color and solubility in water, can help to indicate that certain cations and anions might be present, but this only allow you to make inference on the possibility of the presence of certain ions in the salts. This is because it is possible to have more than one salt sharing the same physical properties. Test for gases. Gases are often produced from reactions carried out during laboratory tests on salts. Gases can be evolved when salts are heated or salts are reacted with acids or alkalis. By identifying the gases evolved, it is possible to infer the types of cations or anions present in a salt. A gas can be identified by its color, smell, effect on litmus paper, and reactions with special reagents. Action of heat on salts. Heating a salt may cause it to decompose. The decomposition may result in a color change, evolution of a gas, liberation of water vapor. Gases such as carbon dioxide, sulfur dioxide, nitrogen dioxide, ammonia, or oxygen can be evolved. By identifying the gas or gases liberated, it is possible to pinpoint the anion present in the salts. Examination of the residue can provide information to identify the cation in the salts. The table shows action of heat on different types of salts. The normal sulfate salts are more stable to heat compared to the carbonates and nitrates. The sulfates of heavy metals are decomposed into metal oxides and sulfur trioxide when heated. Sulfur trioxide is a typical acidic oxide and dissolves in water to form sulfuric acid. An exceptional case is iron 2 sulfate because it also forms sulfur dioxide gas. Ammonium sulfate sublimes when first heated. Further heating decomposes the salts into ammonia and hydrogen sulfate. Identification of salts by action of heat. When a salt is heated strongly, it may decompose. One or more gases may be liberated. Each gas can be identified by noting its color, testing it with moist blue or red litmus paper, testing it with lime water, testing it with glowing wooden splinter, testing it with acidified potassium dichromate 6 solution or acidified potassium manganate 7 solution. The color of the residue when hot and cold must be noted to help in the identification of the salts. Test for anions in aqueous solutions. When a salt is dissolved in water, the free anion will be present in the aqueous solution. Test for cations in aqueous solution. Aqueous solutions containing cations can be prepared by number 1, dissolving a soluble salts in water, and number 2, dissolving an insoluble base in dilute acid. Summary of test on cations using sodium hydroxide solution. Summary of tests on cations using ammonia solution. The color of nickel ion in aqueous solution is green, chromium 3 ion is purple, cobalt ion is pink, and manganese ion is light pink. Confirmatory test for iron 2 ion, iron 3 ion, lead 2 ion, and ammonium ions using other reagents. To identifying the anions and cations in unknown salts. Use the knowledge you have learned about the reactions of anions and cations to help you plan and carry out experiments to identify the anions and cations in an unknown salts. This knowledge can also help you write the correct observations and make inference or conclusions about the identities of anions and cations.